explained deeply what is the first angle projection, third angle projection. So the sectioning that we have started today is 25 marks in the exam. 20 marks in the exam. This sectioning, once you understand the best, it is the same sectioning you find in detailing, which is 20 marks again. It is the same sectioning you find in assembly, which is also 35 marks. That is why we start with sectioning. Once you win this part, no engineering drawings will beat you. Okay? So you have to pay very good attention. I want every single drawing in the page that I've sent you done. Next week. SSD I'll send. Now, in the SSD, now we get started. We can start. SSD, which is the structural steel detailing. Every structure that you find that exists in this earth is supported by structural steel. Bridges, piping system, most of the buildings, the roof. I think you see the roof is structural. Eh? Some they use wood, but the most is steel. You know these workshops, they are all structural steel. So that is why I told you that your course is not just about pipes. No, you need to know it and know it what? Oh, architecture is in your story. That is why after we finish SSD and the mechanical in the next 2 weeks, then we start now the rest of building. These are the 5 subjects you are going to face. And the building is going to run for 3 weeks. Revision for these other subjects will not stop, it's continuous. Okay? So you have to gear yourself with all the strength you have. Now, SSD. I think you see Windows, they have got with burglars. It's all SSD. So it's all over. Even the human body, we have got the structure. It's made of bones. And the aeroplane, what builds the aeroplane? It's SSD, structural steel. That aeroplane, when you use it, has got what? The fuselage. That fuselage is all structural steel before they put the skin outside. So your industry is broader and it has no limits. I think you know the ships, cruise, whatever. It's all structural steel. So you need to know it and know it all. Not half or a quarter. That is why I will not smile with you until you give me the best. Because after this, I need to be very courageous enough to say, can you take my class? Not, can this one take? No. That is why I'm doing this class, because I don't want anybody to say, me, I'm scared. You understand? Thank you. What makes SSD? I want to start from this. On the controversial side, can you see that all the time when I'm drawing, I'm using freehand, and you don't want to give me freehand drawings, And have you observed that if you miss one class of mine, it's a big cost, Okay. I think you can see what it is. These kids are making too much noise. This is a steel section. Okay? These red books that I've given you, they are talking about steel sections. SSD is the comprising of steel sections. So our story is on what? Steel sections and how to use the tables. When we talk of steel sections, we have got the I section, we have got H section, we have got the angle section, we have got the channel section, we have got the square sections. Now, there are many of them. Most of them, they are in this book. Okay? These steel sections, they are named based on this shape, the front view. Some people would consider it as a side view, but this is a front view. They are named based on the cross section. This cross section, that's what makes steel sections. So if it is a I section, this is the I. Can you see it? It's the I. Yes. That is why it's called I section. It is the I. Okay? Then we have got the H section. What is the difference between I section and H section?
Positioning.
I like that. I know that it will be simpler that way. The I and the H says is positioning. But in steel section, steel detailing, what is the difference? What is the difference? What do you think is the difference? Did you hear what I say? No.
Listen.
The thickness.
The height and the breadth is going to be different.
Okay.
Say,
I like it that I'm doing this class because I knew there were some wounds somewhere. Big time. This time I just say I'm taking this class myself. Look here. From there to there. This is the depth. And from there to there is the width. This is known as the flange. Okay? This is the web. You remember the question now, what is the web?
It's the tongue.
I like that. The thing that holds the tongue. A web, it holds two members together. Can you see the web here? There is a flange here, and there's a flange here. A web holds the two flanges together. So like the tongue and the lower jaw, it's held by a small web there. Okay, so this is the flange as well. Now to answer a question, the question I asked, what is the difference between H section and I section? The flange width and the foot depth, they are equal for the H section. They are equal. So, this is B and this is H. For this one, I section, H, small h, is not equal to B. For this one, H is equal to B. That is why when the description is given, it might be said 152 by 152 by certain amount. Because the depth and the width, they are equal for H section. Meanwhile, for I section, H is not equal to B. So I section is a bit higher in depth. Meanwhile, the width is a bit narrow. H section, the depth and the width, they are the same. Does it make sense?
Yes.
Okay. So that is this is the steel section. Then we have got the L shape. We have got two types of angle sections. Two types. The equal leg and the unequal leg. Equal leg, it's equal. This side is equal to that side. Okay? Unequal, one side is longer than the other. Unequal leg, one side is longer than the other. So that is why we have got two types, equal leg and unequal leg. So when we talk of these symbols like this, it means it's like this. If you want to see it in 3D, I'll just do it. This is oblique, ne? When I show it flat like this, then I do. That's oblique. Isometric, it lies at 30 degrees, 30 degrees. So this is the oblique. So you're getting the idea as what is oblique, ne? So this is angle section. Okay? It's angle section, equal leg. If it's an equal leg, this side will be longer than the other. So when I show these symbols, it means that is the thickness. If it's a channel, it will be like this. That's a channel. So it is named because of the cross section. Even this one is named because of the cross section shape. So this is a channel. This is the equal leg, angle section. This is I section. Then we have got H section. We have got square tube. We have got also cylindrical or round tubes. So there are many we have, okay? Everything is here. I'll come to say how do we use this one, okay? Any question, class? Any question? Are we all set? Yes. Thank you. Thank you. I know it's Friday, but to me, no Friday, no Saturday.
Oh, yes.
Only Sunday. I only remember when I go to church to pray, to thank my God for the week. Do you do that?
Yeah.
I don't know. Okay. Yes. Okay. As he is taking picture, is there any uncertainties here? Any question? Okay. We proceed. The question is, how do we draw these drawings of sections? I'll start with the I section. I will erase this. Now we go to the importance of orthographic projection. You think you have left it behind. No. It is following you wherever you go for life. Okay? When you are talking of building designs, it's there. You are talking of structural designs, it's there. You are talking of even equipment, whatever, it's there. Orthographic projection. That is why we have kicked the section in today. Orthographic, we talked about it last week. So, here, let's say I'm looking at this from the front view. This is I'll treat it as front now. Okay? When I'm drawing, I want you to pay good attention. I'm drawing. I think you can see this thickness, ne? Yes. You can see this thickness, ne? Yes. You can see this surface, ne? Yes. What is this? What did we say? What do you do with a web?
The conjunction.
What did I say about a web? I can hear noise. Always, what did you show on a web?
Center line.
Center line. That's what I said. Always a web must go with a center line. Let me finish first drawing. This is the front. I've got the top view, and it is only in SSD where we show the bottom view. Are we together? Only in SSD you show the bottom view. So when I'm drawing the top view, I'll draw it there. I need to show hidden lines. This web here, can you see this web is right in the middle of that? Eh?
Yes.
If you want to visualize, go to my video, watch 100 times.
Yeah.
This web here is in the middle, not on the side. No guesswork here. It's either it's true or it's wrong. If it's wrong, you redo it over and over when I check the files. So here I'm showing this front. It is showing that and that. This one here, it will be shown in the middle here. Is it on the side? It's in the middle because that's where it is when you're looking from the top. Now you, because you're so good, what are you going to do? You even leave them out. Do you know what students do? And that makes me so angry. Okay? What they do, they'll take this drawing, paste it there, without thinking. That must be in your mind. That one. In your mind. So that when you're drawing, you know, this is not that. I don't want to copy and paste. That is laziness. You paste what is wrong. Eh? So, guys, make sure you understand what you're doing. Don't just do it because I want it to be there. The bottom view here. Can you see that my drawings are aligned? You can see they are aligned, ne? And this side you can see it's aligned also, ne? Now you, because you are good, you take this one and put it there, this one there. Where did you take that story? Eh? Now, I've drawn these drawings. Maybe we'll close these windows for now. Okay, fine. Okay. We are lacking now the side views. Don't they have the teacher these ones?
The creative arts, Mr.
Huh?
The creative arts, the only subject we are allowed to make noise.
Oh, I see. Freedom of expression.
Yeah.
You can see how people get iron out there. We mean business now. Yeah, there. Yeah. Okay, the side views. Can you see? Do you know what the students do?
Ah.
Do you know what you do? They'll take this one and turn it this way. They are not the drawings. They don't even talk to each other as long it is there. Eh? For top view. Oh. I give up. Can you see? This drawing can never go with this one. They go side by side with this one. I want to get. Yes. They go side by side with this one. So, the center lines, hidden lines are critical here. Show them where they should be. So, this is a wave. I'll put what? Did I put a center line like this? No. The center line follows the wave. It follows the wave. Its length, its height. Not across. Yes, sir.
So I'm asking for clarity in terms of drawing the top view and the bottom view. I used to use Cartesian pen, then I'll use my 45 degrees. Then from there I'll project the lines of.
That is the orthographic projections rules. It's fine. But what I've seen is what I'm saying. I don't want to see those things. Where you take this, you paste there. It's like you are just guessing as long as it is there. Now we are talking about, you must understand what you're doing.
So,
it has to be ringing in you. Yes.
So what I was doing correct was I will project the. I don't know how to explain on the system. Can you come there and explain?
What you are doing, that is by then. I said, what did I say when you're in this class? Scrap off whatever you knew. Pretend you don't know. So that you get it right for now.
So
Okay?
It was wrong, sir.
I didn't say it was wrong. I'm saying it. I want the work done the right way. Yes.
I think
This one.
then I project for top view.
No. You mean to get the top view.
Yes.
If you take this one, you move it, you turn it, you put it there, get the top view. That is how you are doing it, but I shouldn't see it in the work. Because it's not part of the work. What is part of the work is this arrangement. This arrangement. Not any other arrangement, no. If I want to show two views, I'll take this out, and that out, or that out. I'll show orthographic that way. Why do we draw these views all over like this? Why do we have 4 views around the front view? Why? Somebody to explain to me why. But why? Why are we showing the top? Why are we showing the bottom? Why are we showing the side, 2 side views? Why?
The manufacturer to see Mr. Zed, that is a I section.
Yeah.
I like your answer. This is the reason. Once one of the members, maybe this one, might have the horse there. Then this one has got horse there. Can you see? I need to show the top view to show its details on top. I need the bottom to show its details below. So if I come to the bottom here, I need to show that the holes are here. If I come to this one, I need to show the holes they are here. They are not at the same position. But if I combine these two, I show the holes, they'll be confusing to you. That is why you show the views in their various sides. So that this one talks about it, what is below here. You even show. I need to show that. I need to show. Do you understand? If I don't show this, how is the fabricator, the person welding, going to know? How is he going to know? Remember the difference between fabrication and welding, eh? Fabrication, he makes this, everything, making what? Well, a welder just does what? Welding. So if you say fabrication, you are talking about making the whole thing, walls, whatever is there. So a person doing fabrication must see where these walls are sitting. So don't guess, please. You must know, and know it very well. Why do we need this view? At times, we might have a plate here. Okay? Maybe there's a plate there. Okay. Maybe there's a plate, this plate here, and there are holes on the plate. And this side, maybe there's another plate out here. So, the plate that is this side, I need to show it here. And the moment I show it here, it will block whatever is this side. I must show the plate here as well. Then I'll put the hose. And I need to show the hose there. Now if here the hose they are at different positions, they will confuse your drawing. So I need to show each side what it has. If there's no information here, it's just an eye, I don't need to show that drawing. If there are no holes here, I don't need to show it because there is nothing to show. Only where there is detail, I need to show the details. That is why it's detailing. Does it make sense?
So say, if you interpret, doesn't the eye become hidden? Say?
The eye, it will become hidden, thank you. This one. And you show hidden lines. Thank you. The center lines, you can put center marks, it's okay. Is it making sense now?
Yes.
The drawings must talk. This is orthographic projection. They have to talk to each other. Don't just draw as if you don't care. No. Someone somewhere who is going to be in the accident because of your errors. People have died. You remember Marion Roberts, the bridge when it collapsed? What did they say? We did not cater for wind. Why? Because of the guesswork. When you are doing the designs, you guess. Please, you must know what you are doing and you know it very well. Okay? Any question? Any question? Okay. So if there's no question, I want you to go to this book, Red Book. When you go to this book, it will show you eye section. These numbers here. No, I'm just showing. There is a symbol there to show what it is and the information. You keep going. Then there is H section. We have got two types of these sections. There is a parallel flange and there is the tapered flange. Okay? So you need to understand all those parallel flange or channel, like they might say PC. It's parallel channel. Right. Then you go. All these. So, how do we use this section? I'll take one example. If it is I section, I'll give you to say, I want you to draw I section 254 by 146 by 31 kg per meter. Do we have that one? Did I pick the correct number?
Yes, we have it.
254 on the I section. 254 by 146. Page 2. Can you see that, guys? Page 2. Here. On page 2. You need to check the numbers this side. Then here there are different options. When you get the number, they don't put point something, they round it off here. Ne? What does this mean? What does this number represent? And this one. And this one. Here it represents the depth. But it does not mean that this is the actual number for the depth. No. You need to get the actual number in the table. Here it represents the width. Here it represents the mass per meter. Mass per meter. Out again. So you have got the depth, the width, mass per meter. But are these measurements to use? The answer is no. Go to 254 by 146. Check on 31.3. What is the H? 251.5. What of it is it? 43 kg per meter. 259.6, ne? Because it has changed, it's heavier than the other. Can you see that? So you can have how many types of 254 times 146 according to this? How many of them? There are 3. It's not 1, it's 3. They differ by the weight here. Same measurements, everything, they differ by the weight. But since they differ by the weight, even the thickness, the height, they also differ. Same description. So now, when you look at this table, 254 by 146 by 31, the height, the depth height, this depth height is not the same for all the 3 of them. It's different. Guys, the same tables that you see are the ones that you use when you go advanced in your studies, you are doing strength of materials. You use the same table to calculate. Structural construction designs, you use the same tables to calculate. So this table is used very well. Okay? Very useful. Then what are the, can you see this symbol? It has got abbreviations on it, ne? And those abbreviations, when you follow them on top there, they have shown you what are the numbers. So don't say, where is the radius? Well, no, everything is there. Is that clear?
Yes.
So, once you understand how to read one, it's the same. If you go to H section, it says 254 by 254 by what? You choose also, there are also different types. There are how many here? 5. For H section, there are 5 of them. We can take the first one in 72. kg per meter. Same description. Can you see? This is the depth, this is the width. That's what makes I section and H section different from each other. I section, the width is small. A section, width and the depth, they are equal. Okay. We will continue this lesson Monday, but please start analyzing the tables, understanding. Go and revise on this. The videos will be uploaded. I just need to find time. I just need to find